So where does our power actually come from? In this explainer, we're going to dig into the sources that fuel our world. We'll look at the old workhorses, the new kids on the block, and really get into the nitty-gritty of the price we pay for all of it. All right, so let's jump right in with a question that, honestly, it feels like a bit of a paradox. You probably remember from science class, right? That whole thing about energy being conserved. It can't be created or destroyed, just changed. So if that's the case, how on earth can we have an energy crisis? It doesn't really make sense. We should have all the energy we could ever need, shouldn't we? Well, the secret here is the difference between just plain energy and usable energy. Think about it like this. You've got a fresh, hot cup of coffee. It's packed with heat energy. But what happens? It cools down, and that heat just dissipates into the room. Now, the total amount of energy in the room is the same, but you can't exactly power your phone with that slightly warmer air, can you? So the crisis isn't that energy is vanishing, it's that it's turning into a form that's way less useful to us. And that, right there, is the heart of the energy paradox. The universe is swimming in energy. It's everywhere. The real trick, the challenge we've always faced, is figuring out how to grab it and concentrate it into a form we can actually use to get things done. So first up, let's take a look at the old guard. I'm talking about the conventional power sources, the real engines that literally built the modern world we live in today. And at the very top of that list, of course, are fossil fuels. We're talking about coal and oil, stuff that formed from, well, ancient life, millions and millions of years ago. These fuels kicked off an explosion of growth like nothing the world had ever seen. They're the reason we have our massive cities, our humming factories. They're what put us all on the road. But you knew there was a but, right? All that progress came with a really steep price tag. I mean, the biggest problem is that they're non-renewable. When we use them up, that's it, they're gone. And on top of that, burning them pumps all sorts of nasty stuff into the air, things that cause acid rain and, of course, the greenhouse effect, which is actively changing our planet's climate. Okay, so what's really fascinating is that when you boil it all down, the basic recipe for making most electricity is surprisingly simple. It's all about one thing: spinning a turbine. Seriously, it doesn't matter if you're using steam or wind or falling water, the end goal is almost always to just get something to spin. Yeah, and you can see that principle right here. You can burn coal, make a bunch of steam, and use that pressure to spin a turbine. Or you can let water rush down from a dam to do the exact same thing. It's all about converting one kind of energy into that spinning motion that a generator needs to make electricity. So let's stick with that idea of falling water for a second. Hydropower. It's a real giant in the world of conventional energy. What we do is we build these massive dams to stop a flowing river, turning all that moving energy into stored, potential energy. It's a huge deal. I mean, in a place like India, hydropower accounts for something like a quarter of the country's entire energy supply. But, and this is a big but, there's a major trade-off. On the one hand, yeah, you get renewable energy, you get flood control, and you get water for farming. All good things. But on the other hand, you have to flood enormous areas of land. That means people lose their homes, entire ecosystems get wiped out, and all that drowned vegetation, it rots and releases methane, which is a really, really powerful greenhouse gas. You know, it's interesting, even with our most ancient fuels, you can see this constant push to get more efficient. Take wood. It was probably our very first fuel, right? But it's super smoky and doesn't burn all that hot. So what did we do? We figured out that if you heat wood with just a little bit of oxygen, you get charcoal. A simple little upgrade that burns way hotter and cleaner. It's all about getting more bang for your buck from the same basic material. And that story of progress just keeps going with what we call biomass. Instead of just burning waste, we've gotten a lot smarter. Now we can take stuff like cow dung, leftover crops, even sewage, and put it into a biogas plant like this one. Inside, without any oxygen, tiny microorganisms just go to town and break it all down. And what comes out the other end is biogas. And this stuff is an amazing fuel. Why? Because it can be up to 75% methane. It burns super hot, with no smoke, and leaves basically nothing behind. And get this, the gunk that's left over is an incredible fertilizer. So you're turning waste into two useful things, energy and fertilizer. It's a total win-win. All right, so that's the old school. Now let's switch gears and talk about the new contenders on the block, the alternative energy sources. These were basically invented to try and solve all the problems that the conventional ones created. Let's start with wind power. I mean, The amount of pure kinetic energy in the wind is just mind-boggling. To give you some perspective, it's estimated that a country like India could generate a whopping 45,000 megawatts just from harnessing its wind. That is a ton of power. But again, there's always a but. Tapping into that potential isn't so easy. For one, you need a lot of land for a wind farm, a whole lot. Then the wind has to be blowing at a pretty steady clip, over 15 kilometers an hour, to even be useful. The startup cost is huge. And, the wind isn't always blowing, right? So you always need to have some kind of backup power ready to go. Okay, next up, the big one, the source of pretty much all energy on Earth, the sun. And what's cool is that we can tap into its power with some really simple tech. This here is a basic solar cooker. It's literally just a box painted black on the inside to soak up heat with a glass lid to trap it. It creates its own mini greenhouse effect right inside the box, and that's enough to cook food. And this simple box is a perfect example of the classic renewable energy trade-off. The good parts? They're amazing. The fuel, sunlight, is totally free. And it's completely pollution-free while it's running. But the downsides are all about availability. You can't cook dinner when the sun's down, you can't use it on a cloudy day, and it's definitely not as fast as just turning on your oven. Then you've got the ocean. Talk about a powerhouse. There's energy in the tides, which are super predictable, and there's energy in the constant motion of the waves. The potential there is absolutely massive. The problem, actually building stuff that can survive in the ocean and capture that energy reliably and cheaply, well, that's a tough engineering nut to crack. And then there's nuclear. This is about unlocking the insane amount of power that's locked inside an atom. Right now, every nuclear reactor on the planet uses a process called fission. That's where you take a big, heavy atom like uranium and split it apart, which releases a ton of energy. But the ultimate goal, the thing scientists are chasing, is fusion. That's smashing tiny atoms together. It's literally how the sun makes energy, and it releases even more power. But with all that incredible power comes some pretty incredible risks. The possibility of a major accident, while low, is terrifying. And we still, to this day, don't have a great permanent solution for what to do with the radioactive waste, which stays dangerous for thousands of years. When you add the massive cost of building these plants, you can start to see why nuclear is one of the most controversial topics in energy. So, where does that leave us? Well, it brings us to the one big, unavoidable truth in all of this. When it comes to powering our world, there's no free lunch. There's no magic bullet. There are only trade-offs. Yeah, we throw around the term clean energy a lot, but this quote really hits the nail on the head. It's all relative. It's more accurate to say one source is cleaner than another, because they all have an impact. Fossil fuels pollute the air, we know that, but building a dam floods a valley. Even a solar panel has an environmental cost from the mining and manufacturing it takes to create it. And so that leaves us with the ultimate question, doesn't it? Every single energy source has a cost, whether it's measured in dollars, in damage to the environment, or in its impact on communities. The challenge isn't finding one perfect source. It's deciding which mix of imperfect options we, as a society, can live with. So the real question to think about is, what price are we willing to pay?